works extensively on CDISC standards and has presented a paper on atom datasets in PharmaSUG last year, 2015. Sunil, Master of Science, is a certified SAS programmer. He's a senior statistical programmer working also at Inventive Health, and has been using SAS for more than 7 years in pharmaceutical industry. He has experience with different therapeutic areas and CDISC standards.
Thank you. Hi everyone. I'll be going first, talking about indexing, talking about various types of indexes, talking about how we create various types of indexes, and then my friend Arun will take over and we will be talking about how to exploit indexes. So the topic of our presentation is indexing, a powerful technique for improving efficiency. The first slide, it shows there are 2 points, point A and point B. So what we are talking about is, say we want to go from point A to point B. If we want to travel from point A to point B, we have 2 goals, a primary goal and a secondary goal. The primary goal would be to travel from point A to point B within specific time, and our secondary goal would be to travel from point A to point B within specific time efficiently. So with terms of efficiency, I mean probably using less gas or following the shortest route. Similarly, in programming, all of the programmers have primary goal and secondary goal. Primary goal would be getting the right results out. The secondary goal would be getting the right results out efficiently. So the focus of this paper is about efficiency, and that's why we took this example. So what efficiency means with respect to programming here. So efficiency with respect to programming is defined as, like, if we have a huge data set and we write a code to do some manipulation in the data set, that program should execute with less amount of resources, more rapidly within less amount of time. It should utilize less memory. It should utilize less CPU, input-output resources, and other resources. All right. So, what is indexing? The best way to think about indexing is think about a book, probably a 2,000-page book, without a table of content. And then, if we want to find a topic, a particular topic, or search about a particular topic here without a table of content, we might have to go page by page sequentially, starting from page 1, and probably we might be able to locate our topic, but it would take too much of time. Now think about the same 2,000-page book with a table of contents. You want to look for a certain topic. You just go to that particular page, point at that page, and you are there. And that's exactly what indexing will do. It will save us time. So index files in SAS. Well, when we create an index, our index file would be, there will be only one index file per data file. And indexes are stored in separate ways in different environments. So if we talk about Windows environment, the index file would be stored separately from the data file. But it would have same name as data file. When we talk about Unix environment, index file would be the part of data file. And this figure here, or this picture here, is representing an index file. And the index file consists of 2 things, which is a distinct value and RID, which is a unique record identifier. So over here, the value consists of a variable called last name. And as we can see, the last name, Emery, Brown, Gray, and then right adjacent to it is the unique record identifier, which tells us that the last name Raj occurred at observation 2 and 45, Dunn occurred only once in the data set at 1, and Brown, which occurred at 6, 22, 43. So when do we index? How do we improve efficiency? The question is first, what considerations do we take while creating an index? So we always have two considerations. The first would be to always subset, probably try to subset 1 to 15% of the total number of observations work so that index works efficiently for you. And if you increase more than 15%, it will still work, but not as efficiently as we would like it to be. Anything above 30%, if we try to create 30% of the total subset, if we try to create an index, it may not be a good idea to create index at times. And the second consideration to create an index would be the frequency of use. So we all know that it takes time, it takes resources, it takes input-output resources to build an index. So the more frequently we use, the more the better. Otherwise, it would be more of an overhead expense rather than being of some help. So the key variable candidates to create an index. So the variables to index should be the variables that are used in queries. And the other thing that to take into consideration is the variable should be very discriminating or should have very unique values. The more discriminating the variable is, or more discriminating values the variable has, the much better it is for index, much better candidate it is for indexing. So for example, I can look at a DM data set, a demo data set, which has age, gender, SSN. So if I create an index of gender, it may not be a good idea because we have probably out of 1,000 observations, we'll have maybe 600 males or 400 females or vice versa. But if we take SSN as a unique, as an indexing variable, we'll have distinct values for all 1,000 observations. So always try to create, take a variable with discriminating values. And there are two types of indexes. The first would be a simple index, and second would be a composite index. What's the difference between simple and composite? Would be a simple index consists of values for one variable. A composite index will consist of values from two variables concatenated into a single value. So what are the tools that you can use to create index? So there are three ways we can create indexes with. First one is proc dataset, second is proc SQL, and third would be DRMT. We'll look into detail proc dataset. So as we discussed, there are two types of indexes, and there are three ways to create indexes. So altogether, we'll see in the next three slides, we'll see 6 types of indexes. Now, a simple index would be created very simply by using index create CD number. So a simple, if you see a CD number is actually a variable inside the data set. So the index which is created by using the variable CD number has the same name. So we are creating index CD number. But if you look at composite index, as we discussed, we are using two variables here. We are using CD number, we are using artist names. So we are creating a new name for it. This is another example, the second type, which is using PharmaSUG. PharmaSUG, again, we are trying to create a simple index and a composite index. So simple index, again, as you see here, is CD sales, CD number, which is being created. And in the composite index, we have again num name, which is being created on two variables, CD number and artist name. The third one, which we are talking about, is the data step. Is another way to create an index, again simple and composite. Again, the same thing to be noticed here. And now, the next part of the presentation is exploiting index, which I think my colleague Arun will take over.
Thanks, Neil. All right. So now that we have seen what exactly an index is, different types of indexes, and how to create indexes in different ways in base sets, we want to know how exactly we can exploit those indexes that we have already created, all the data sets that are already existing in our libraries. So in base SAS, we have 4 different ways in which we can exploit the index that we have already created. There are a lot of other ways in other SAS applications, but that's not covered in this presentation. So we're focusing only on the base SAS program. So the 4 different ways are, number 1, we can use an indexed variable in the where statement, which is one of the ways. We can use an indexed variable. It could be simple or composite index. In a by statement, we can use it in the key option with the set statement or with a modified statement. And we're going to see these things in detail with some examples, sample codes in the next 4 slides. All right, so this is the very first way, one of the ways of using or utilizing your index that you have already created, using the where statement. It can be used in the general data data step. It looks exactly like the regular where statement that you use, but just that the CD number, what you see right here, is a variable that presents in all its data set, and then an index has already been created on this variable. So when you use this variable on which an index is already created, SAS is going to know that this is an index file, and it has to be processed differently than a regular where statement. The main difference is that when it is a regular variable CD number without any index, SAS is going to look up the data set observation by observation starting from the very first one in a sequential manner. So if you have 1,000 observations in your data set, it's going to look it up starting from observation number 1 and go all the way down till it finds a match for 1, 2, 3, 4, 5, 6 in our example. But when we create an index variable and then we use it in the where condition like that, what's going to happen is SAS will understand it has an index already created, and it's going to look up in the index file. It's not going directly to the data file. Instead, it goes to the index file, and it does a search on the value 1, 2, 3, 4, 5, 6 in the index file. And one more thing to be noted down here is that when it searches in the index file, it's not going to search in a sequential way. It's going to use a different algorithm altogether. It could be a binary search algorithm, or it could be any other efficient algorithm other than the sequential process. That's when you really save the time. All right, the second way you can utilize or exploit an existing is using it in the by statement. The use here is actually to sort the data set. So you have an input data set called all hits, and you're trying to create an output data set CD sales, and you're using the by statement with the index variable. In this particular example, we're actually using a composite index. So 2 variables, CD number and artist name, which is already present in the data set all hits, are used to create a composite index, and then we are using that for sorting the data set. Again, like I said, when we use this on indexed variables, SAS is going to know it has an index variable already created, and instead of using the sequential regular processing for sorting purpose, it's going to use other efficient algorithms. The benefit here is you can completely avoid the proc sort. You don't have to do a proc sort in order to sort the data set by these variables after this data set. That's one thing. Second thing, if you compare the proc sort procedure efficiency and the index usage efficiency, the index one is going to be more efficient. So you're saving in terms of time as well as in terms of coding. So this is the third way you can utilize or exploit an index. To understand this concept, we should probably focus a little bit on the master file, transaction file concept. So we have a master file here. Now, if you want to add some more information to your transaction file hits from your master file, you could do it this way using an index file, index variable. In this case, our index variable is CD number, and we use the key equal to option to pass the index variable so that the input data set will have additional variables taken from the master file, all hits, and the CD sets will be created with the final one. Now, you could do the same thing using a regular merge. I'm sure you would have thought about it right away. You could do the same thing using a merge statement and a by statement. But what's the difference? Again, the difference is that when you use the merge statement and the by, it's going to process it sequentially. It's not going to look it up using a lookup table concept, and it's not going to save you much time when you compare them to the indexing concept. But when you use this method using the key equal to index variable, it's going to do the table lookup thing, and it's going to use a different efficient algorithm in order to find and merge the values with your data set hits and get it out as a CD6. So now we have seen 3, we're going to see the 4th one. This is the 4th one. This is using the key option in a modify statement. We all know that modify statement is used to modify the values of variables or for all the observations for an existing data set. So we could use the index variable, the key option right here. In this case, it's a simple index. We're using CD number, simple index as the key option here. Again, like in the previous example, we have the master file, transaction file concept here. We have the master file as the current.cd sales, and we have a transaction file called update.sales. So some of the observations for some of the variables has to be updated using the sales data set. And we could do this again with the regular modify statement without key. When it is regular, we would mention the current.cd sales in the modify statement first, followed by the transaction file without the key, and you could use a by statement. You could do it that way too. But when you do it this way, it's going to look up the index file for this particular key, whatever is there in the sales, and it finds the observations that matches with the master file observation where it matches the CD number, and it's going to directly access those observations and update only those. So it's not going to read it sequentially. It's not going to go from the observation number 1. It directly goes there and updates that. So sort of a direct access, if you could consider it that way. This is just a demonstration. We have taken a sample lab data set in our study. It has got 139,775 observations in that, and we tried subsetting that. We just wanted to pull out only 421 observations out of it. So we tried doing the same thing, the regular where statement, and then we tried using the same process by creating an index on the lab data set. So the difference we found was this: when we really used the regular method, it took like 0.22 seconds, and when we used the indexing, it took only like 0.05 real-time seconds that you can see here. So as you can clearly see, the efficiency of using an index file is like well over 77.3%. But this is just a small data set that we're talking about, like phase 4 studies of integrated analysis and huge lab data sets where the number of observations is much, much more. And if you want to pull out small portions of that, this efficiency is going to go well over 90%, which really matters when you're running batch files, and especially you're running multiple programs over and over and over again. So the index used here is lab rec on these 3 parameters, and this was a filtering condition. So the conclusion is that you could always use index when you have an opportunity. You always have filtering conditions in your applications. We have already seen that index is best used and best efficient when it is used to subset a very small portion of observation from a huge data set. We also have seen how to identify the best possible candidates for indexing variables. We understood the difference between a simple index and a composite index. We know how to create index in base SAS using 3 different tools, and we have also seen exploiting index using the 4 different methods in base SAS. Questions?
Can you give an example of indexing algorithm?
What's that?
Can you give an example of an algorithm that the indexing will use?
Oh yeah, sure. The binary search algorithm is the best example that could be used. So for example, you have have 10 observations in a data set. Starting from, let's say our indexing variable is ID, which is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you are passing a where condition where ID equal to 5. So usually what happens is if it is a regular data step, it's going to go to the observation number 1 and see if 1 matches with 5. It doesn't match. It goes to the next observation. Again, next observation. So it's going to take 5 steps before it's going to find the right observation which matches the number, right? But when we use indexing, what's happening is it's going to directly go to the index file, and then the number 5 will be compared with the first and the last value in the index. It's going to compare 1 and 5, 1 and 10 with 5, and it finds that 5 is above the midpoint portion. First thing is it takes the midpoint. It's 1 and 10. It finds the midpoint portion, which is like 5, right? So then it understands that 5, our input value is within 5 and 10. It's not between 1 and 4. So 1 and 4 observation is gone. It's not going to look it up again. So it takes 5 and 10. And then it again does the same algorithm on that subset and it finds. So the number of steps will reduce drastically. Maybe you will get that in 3 steps. But in our example, the total number of observations is only 10 and we are looking at 5. What if our number of observations is like 1 million and we are trying to look at the 1 millionth observation? So sequential processing will take 1 million steps, but binary processing is going to take maybe 25 or 55 steps. I don't know, it's just not good enough, but that's the improvement you're looking at.
We need to stop.